All right, folks, pull up a chair. You know me. I've spent a good chunk of my life crawling through the muck and mire, seeing how things get made, how the world works. And let me tell you, I've seen some incredible ingenuity out there. Some real smart cookies trying to make things better, faster, stronger. Welcome to our deep dive into 5 groundbreaking construction technologies that could revolutionize the way we build but are being held back by politics, regulations, and industry resistance. It's a story I've seen play out 100 times in 100 different places. Good ideas getting tangled up in red tape or stomped on by folks who like things just the way they are. Now, I'm not one for pie-in-the-sky dreaming without a healthy dose of reality, but when you see technology that could put roofs over more heads, make buildings that are kinder to the planet, and stand up tougher against whatever Mother Nature throws at us, you've got to ask, what's the hold-up? It's usually not the science, not the engineering. More often than not, it's us, the human element, getting in the way. We're talking about innovations that aren't just fancy gadgets, they're potential game changers for how we live. So today we're going to roll up our sleeves, not to get dirty this time, but to take a hard look at these promising construction methods. We'll explore what they are, what they could do for us, and perhaps most importantly, why they're stuck in second gear. Maybe, just maybe, by shining a light on these things, we can get a few more gears to engage. Because honestly, some of this stuff just makes too much sense to ignore. Let's get into it. All right, first up, let's talk about three-dimensional printed houses. Now, when you hear three-dimensional printing, you might think of little plastic trinkets, keychains, maybe some fancy doodad for a spaceship. But imagine a giant nozzle, extruding concrete or some other composite material, layer by layer, building the walls of a house right before your very eyes. I've seen some wild stuff in my day, but watching a house essentially print itself into existence in 24 to 48 hours, that's something else. It's not science fiction anymore, then it's happening. The sheer speed is one thing, but then you look at the cost. We're talking a fraction of traditional stick-built or brick-and-mortar construction. Think about that for a second. In a world where affordable housing feels like a pipe dream for so many, where homelessness is a persistent shadow in even the wealthiest nations, this technology pops up and says, hey, I can help with that. Big time. It's a powerful promise, the kind that makes you sit up and pay attention, or at least it should. This isn't just about cutting corners or making cheap knockoffs. The precision of these machines can lead to less waste, more intricate designs, and homes that are just as sturdy, if not more so, than what we're used to. The potential to rapidly deploy housing after a natural disaster, or to quickly build communities in developing areas, is just staggering. It feels like one of those common-sense solutions that should have everyone nodding their heads and saying, let's do this. But then, reality, as it so often does, throws a wrench in the gears. The first big hurdle, building codes. Now, I've tangled with my share of regulations and inspectors, and I understand the need for safety, for standards. But many local building codes were written long before anyone imagined a house could be spat out by a giant printer. They simply don't have a box to tick for extruded concrete dwelling layer cake style. So the default answer is often no, or at least not yet. We need to study this for a decade. And then you've got the human element, specifically the construction unions and legacy industries. Look, I've got immense respect for skilled trades. These are the folks who build our world, often in tough conditions. But when a technology comes along that promises to do the job with fewer hands or different skills, you can bet there's going to be resistance. It's human nature to protect your livelihood, your craft. The fear of automation is real, and it's a powerful force pushing back against this kind of innovation. It's not just the folks on the tools either. Think about the established industries. Lumber, brick manufacturing, traditional home builders with their decades of investment in current methods. A widespread shift to three-dimensional printing would mean a major disruption to their markets, their supply chains, their bottom lines. They're not exactly going to roll out the welcome mat for a technology that could make their existing business models less relevant. It's the classic innovator's dilemma writ large on the landscape of our towns and cities. I've seen pilot projects, small-scale communities being printed, and the results are often impressive. People are living in these homes and they're safe, they're comfortable. You see a family get keys to a home that was just a patch of dirt 2 days prior, and it's hard not to feel like you're witnessing something truly revolutionary. It's the kind of progress that gets you excited about the future, makes you think we can actually solve some of these big, thorny problems. So what's the path forward? It's going to take a concerted effort. Building codes need to adapt to become more flexible and performance-based rather than prescriptive. We need to have honest conversations about workforce transition, about how new technologies create new kinds of jobs, even as they change old ones. It's not about throwing the baby out with the bathwater, but about finding a way to integrate these new tools intelligently. The frustration comes from seeing the potential so clearly. Imagine the impact on global housing shortages, the dignity restored when a family has a safe, affordable place to call home. It's a massive opportunity, a chance to build better, faster, and more affordably. But it's an opportunity that's currently being throttled by a reluctance to change, by a system that often favors the familiar over the innovative. Ultimately, for three-dimensional printed houses to truly take off, there needs to be a shift in mindset. From policymakers who are brave enough to update outdated rules, to industries willing to adapt rather than just resist, and even to communities willing to embrace a new look for their neighborhoods. It's a tall order, I know. But the alternative is to keep doing things the same old way. While the problems these technologies could solve just keep getting bigger. That doesn't strike me as a particularly smart plan. Next on our list is something called hempcrete. Now, before your mind wanders off to Cheech and Chong, let's be clear, we're talking about industrial hemp, the sober cousin in the cannabis family, the one that's all business and no party. Hempcrete is a fascinating material made from the woody inner core of the hemp stalk, mixed with a lime-based binder and water. Sounds simple, right? Well, the benefits are anything but. This stuff is sustainable for starters. Hemp grows fast, requires relatively few pesticides or herbicides, and actually absorbs carbon dioxide from the atmosphere as it grows. When you use it in construction, you're essentially locking up that carbon in the walls of your building. That makes hempcrete not just carbon neutral, but often carbon negative. In a world increasingly worried about climate change, that's a pretty big deal. It's like the building itself is doing its part to clean the air. But the good news doesn't stop there. Hempcrete is remarkably fire resistant. I've seen videos of people taking a blowtorch to a hempcrete block, and it just chars a bit on the surface. It doesn't really catch fire or spread flames. Try that with a traditional wood-framed wall. Plus, it's an incredible insulator. We're talking walls that breathe, regulating humidity naturally and keeping the inside cooler in the summer and warmer in the winter, which means lower energy bills. So, you've got a building material that's good for the planet, safe from fire, and saves you money on heating and cooling. Sounds like a no-brainer, doesn't it? You'd think builders would be lining up to use this stuff, and homeowners would be clamoring for it. But as you might have guessed, there's a but. And it's a big one, rooted in decades of misunderstanding and, frankly, some pretty stubborn regulations. The biggest hurdle for hempcrete has been its association with marijuana. Even though industrial hemp has negligible levels of THC, you could smoke a whole field of it and get nothing but a sore throat. The stigma persists. For many years, growing hemp was illegal or heavily restricted in many countries, including the United States. That put a major damper on research development and the establishment of a supply chain for building-grade hemp. Even with recent legal changes that differentiate industrial hemp, the regulatory hangover continues. There's a significant lack of standardized building codes specifically for hempcrete. Builders and architects thrive on predictability and accepted standards. If there isn't a clear set of rules and testing protocols for a material, it's much harder to get permits, insurance, or financing. It becomes a risky proposition, even if the material itself is fantastic. Think about it from an inspector's point of view. They're used to seeing wood, concrete, steel. You show up with walls made from a plant mixed with lime, and their manual probably doesn't have a chapter on that. It takes time, education, and a willingness from regulatory bodies to develop and adopt new standards. And that process, as we all know, can be painfully slow, especially when there isn't a massive industry lobby pushing for it. The potential here is enormous, though. Imagine entire neighborhoods built with materials that actively reduce our carbon footprint, homes that are naturally more comfortable and require less energy to live in, buildings that are more resilient to fire, which is a growing concern in many parts of the world. Hempcrete isn't just a niche eco-product, it could be a mainstream solution for creating healthier, more sustainable and more resilient communities. It's a classic case of perception and policy lagging far behind innovation. The science is there, the practical benefits are clear, but breaking through the old ways of thinking and the entrenched regulatory frameworks is a monumental task. It requires advocates, educators, and pioneering builders willing to navigate the bureaucratic maze and prove the viability of the material, one project at a time. What we need is a more enlightened approach. Governments need to streamline the approval process for sustainable materials like hempcrete, invest in research to standardize its use, and perhaps even incentivize its adoption. The construction industry needs to be open to learning about and incorporating these new methods. It's about looking at the long-term benefits, not just the short-term familiarity of traditional materials. Because if we're serious about building a greener future, hempcrete offers a pretty compelling blueprint. All right, let's get down to earth with our next one, literally. We're talking about earthbag or super adobe construction. Now, this might sound a bit primitive to some, like something you'd do if you were stranded on a desert island, but stick with me here because there's a certain rugged genius to this method. Essentially, you're using bags, think long polypropylene tubes or individual sandbags, filled with local soil sand or sometimes a mix with a bit of cement for stabilization. You lay these bags in courses, like oversized bricks, tamping them down good and tight. Often you'll run strands of barbed wire between the layers, which acts like a kind of Velcro, locking everything together and providing tensile strength. The result? Incredibly strong, load-bearing walls that can be shaped into domes, vaults, or more conventional straight walls. And the cost? Well, your main material is often right under your feet, dirt. It doesn't get much cheaper than that. Beyond the ultra-low cost, one of the most striking benefits of earthbag construction is its resilience, particularly against earthquakes. The monolithic, compressive nature of the structures, especially domes, makes them incredibly stable when the ground starts shaking. I've seen examples where traditional buildings have crumbled and the earthbag structures nearby are still standing strong. That's a pretty compelling argument in disaster-prone regions. So you've got a building method that's incredibly cheap, uses readily available local materials, is earthquake resistant, and with a bit of plaster or adobe finish can actually look quite beautiful and unique. You'd think this would be a go-to solution, especially in developing countries, rural areas, or places recovering from natural disasters where resources are scarce and the need for shelter is urgent. But here's where we hit the wall, and it's not made of earth bags. The biggest problem is that this method is often not recognized by most building authorities. Your local planning department, your building inspectors, they've got their books, their codes, their approved materials lists, and long bags filled with dirt usually isn't on page 1 or any page for that matter. It's outside the box, and for many bureaucracies, outside the box means no. Then there's the aesthetic and social bias. Let's be honest, for many folks, the idea of living in a dirt house, no matter how structurally sound or well finished, just doesn't sound appealing. It sounds like a step backward, not forward. We've been conditioned to see certain materials, brick, wood, concrete, steel, as symbols of permanence and progress. Earthbag structures, with their often organic, unconventional shapes, can face a kind of not-in-my-backyard resistance simply because they look different. This bureaucratic and social inertia is a powerful thing. It's easier for an official to deny a permit for something they don't understand or that isn't explicitly covered by existing regulations than it is to champion an innovative, low-cost solution. It requires courage, a willingness to learn, and sometimes a fight against the status quo. And let's face it, those aren't always abundant qualities in large institutions, yet the potential here is just immense, particularly for providing ultra-low-cost, resilient housing. Think about refugee camps, post-disaster rebuilding efforts, or communities struggling with extreme poverty. The ability to empower people to build their own durable shelters using local materials with minimal specialized skills is revolutionary. It's a direct answer to a fundamental human need. It makes you wonder, doesn't it? We spend fortunes on complex aid programs, yet here's a simple, effective technology that could make a massive difference, and it's often sidelined because it doesn't fit neatly into our preconceived notions of what a proper house should be or how it should be built. It's a classic example of common sense getting tangled up in red tape and cultural biases. To move forward, we need more demonstration projects, more education for both the public and for building officials. We need engineers and architects to develop standardized plans and testing data that can satisfy safety concerns. And perhaps most importantly, we need to challenge our own perceptions about what constitutes adequate and dignified housing. Maybe a house built from the earth itself isn't primitive, maybe it's profoundly sensible. All right, let's talk about concrete. It's the most widely used man-made material on the planet. Our cities, our roads, our bridges, they're built with it. But traditional Portland cement, the key ingredient in most concrete, has a dirty little secret. Producing it is incredibly energy intensive and releases a massive amount of CO2 into the atmosphere. We're talking something like 8% of global CO2 emissions. That's a huge environmental footprint. Now, what if I told you there's an alternative, a type of concrete that's not only stronger and more durable than the regular stuff, but also slashes those CO2 emissions by a whopping 80 to 90%? It's called geopolymer concrete. Instead of Portland cement, it uses industrial waste products like fly ash from coal power plants or slag from steel manufacturing as binders activated by alkaline solutions. It's like taking industrial leftovers and turning them into super strong building material. Think about that for a moment. Stronger, more durable buildings that last longer, requiring less maintenance and replacement, and at the same time dramatically reducing the carbon footprint of construction. One of the world's biggest industries. This isn't some minor tweak. This is a potential revolution in how we build the very foundations of our civilization. It sounds almost too good to be true, doesn't it? The benefits are clear. Geopolymer concrete can be more resistant to fire, to chemical corrosion, and it cures faster than traditional concrete, which can speed up construction timelines. Lower lifetime costs because of increased durability, and a massive win for the environment. You'd think every construction company, every government, every engineer would be jumping on this like a trampoline. But as with all good ideas that challenge the status quo, there's a catch, and in this case it's a pretty big one. The existing cement industry. We're talking about a global behemoth, a multi-billion-dollar industry with deeply entrenched infrastructure, supply chains, and, let's be frank, a very powerful lobby. They've spent over a century perfecting and promoting Portland cement. They're not exactly going to cheer for a disruptive technology that uses less of their primary product. This isn't a conspiracy theory, it's just business. When you have that much invested in a particular way of doing things, change is seen as a threat, not an opportunity. So while geopolymer concrete has been around in various forms for decades, its widespread adoption has been incredibly slow. There's a lack of broad industry standardization, which makes engineers and builders hesitant. They like to work with materials they know, with well-established codes and practices. Then there's the issue of investment, scaling up the production of geopolymer concrete activators, and ensuring consistent quality of the industrial byproducts used as binders requires significant capital. Without strong market demand or government incentives pushing for change, that investment often lags. It's a bit of a chicken and egg situation. Builders won't use it until it's widely available and standardized, and producers won't scale up until there's clear demand. The climate benefits alone should be enough to make this a top priority. If we're serious about meeting carbon reduction targets, transforming how we make concrete is not just an option, it's a necessity. Imagine the impact if even half the concrete poured globally was geopolymer. We're talking about a massive reduction in greenhouse gases, equivalent to taking millions of cars off the road. It's frustrating to see a technology with such clear advantages being held back by inertia and vested interests. It requires a paradigm shift, a willingness to look beyond the upfront cost of changing systems to the long-term benefits of more durable infrastructure and a healthier planet. It needs champions in government, in academia, and within the construction industry itself. The path forward involves more research to refine formulations and establish robust international standards. It means educating engineers and architects about its properties and applications. And yes, it probably means creating policies that encourage or even mandate the use of lower carbon building materials where appropriate. Sometimes the market needs a nudge or even a firm push in the right direction, especially when the stakes are this high for all of us. Last but not least, let's talk about modular or prefabricated housing, specifically advanced systems. Now, when I say prefab, some folks might picture those flimsy cookie-cutter boxes from decades past. But we're not talking about your grandma's double wide here, though there's a place for those too. Modern modular construction is a whole different ballgame. We're talking about homes, or sections of homes, built in a climate-controlled factory setting to incredibly precise standards. Think about it like building a car on an assembly line. Each component is crafted and assembled under optimal conditions with rigorous quality control at every step. Then, these completed modules, entire rooms, or even whole sections of a house are transported to the building site and craned into place. The on-site work is drastically reduced, mostly focused on assembly, foundation and utility hookups. The advantages are pretty compelling. First, speed. A home can be manufactured in the factory while the site work is being prepared simultaneously. This can cut overall construction time by weeks, even months. Second, cost. Factory efficiencies, bulk purchasing of materials and reduced labor hours on site can lead to significant savings. And third, quality. Building indoors means no weather delays, no materials exposed to rain or snow, and a consistent level of craftsmanship that can sometimes be hard to achieve on a chaotic outdoor site. Plus, factory construction typically results in much less material waste. It's a more controlled, more efficient process all around. So, faster, cheaper, often higher quality and more sustainable. It sounds like the perfect solution, especially for addressing housing shortages in rapidly growing urban areas or for projects where time is of the essence. You'd imagine our cities would be embracing this with open arms, but as you've probably come to expect by now, there are roadblocks. One of the biggest, zoning laws. Many municipal zoning codes are archaic, written long before advanced modular construction was a thing. They might have outdated restrictions on manufactured housing, or prescriptive requirements that inadvertently make modular projects difficult or impossible. Getting these codes updated is a slow, bureaucratic slog. Then you run into the classic NIMBY problem, not in my backyard. Some people hear factory-built or modular and they immediately picture something undesirable, something that will lower their property values. There's often a stigma, an unfair perception that modular housing is somehow inferior despite modern designs often being indistinguishable from or even superior to site-built homes. Overcoming these public perceptions takes education and showcasing high-quality examples. And of course, there's resistance from some traditional builders and trade groups. Just like with 3D printing, the idea of homes rolling off an assembly line can feel threatening to those whose business models are based entirely on site-built construction. They might fear disruption of their market, a shift in the skills required, and a change in how the whole industry operates. Change is uncomfortable, especially when you're comfortable with the way things are. The potential to scale urban housing solutions is enormous, though. Imagine being able to rapidly deploy well-designed, durable and affordable apartment buildings, townhouses or single-family homes in areas where they're desperately needed. This isn't just about putting up boxes. Modern modular allows for incredible design flexibility, creating attractive and livable communities. It could be a game-changer for tackling urban sprawl and housing affordability crises. We're seeing some fantastic innovation in this space, multi-story, modular apartment buildings, beautiful custom homes, even entire hotels being assembled in record time. The technology is there, the capability is there. What's often lacking is the political will, the regulatory framework, and the public acceptance to let it flourish on a wider scale. To unlock this potential, we need more progressive zoning policies that embrace innovation in housing. We need better public education to dispel outdated myths about prefab. And yes, the traditional construction industry needs to see modular not just as a threat, but as an evolution, an opportunity to build more efficiently and sustainably. It's about adding another powerful tool to the toolbox, not throwing the old ones away entirely. The factory of the future could be building the homes of the future if we just clear the path. So there you have it. 5 technologies that are not just pipe dreams but real, tangible ways to build better, smarter and more sustainably. From houses printed in days to concrete that eats CO2, from dirt-cheap shelters to factory-built quality, the ingenuity is astounding. These technologies have the potential to democratize housing, reduce climate impact and improve resilience across the globe. It's the kind of stuff that gets you excited about what's possible when smart people put their minds to solving big problems. But as we've seen, having a great idea, even a revolutionary one, isn't always enough. The path from innovation to widespread adoption is often littered with obstacles. Regulations designed for a bygone era, corruption that favors the connected and entrenched industry, interests that resist change at every turn. These are the headwinds that can stall even the most promising advancements. It's a story as old as time, but one we need to keep challenging if we want to move forward. The question is, what do we do about it? Do we just shrug and say, that's the way it is? Or do we start asking tougher questions, demanding more from our policymakers and supporting those who are trying to push these boundaries? Want a deep dive into any of these technologies? Maybe you're curious about a side-by-side visual comparison of these methods against traditional building, or a detailed breakdown of the economic impact if they were widely adopted. Let us know in the comments, because the conversation doesn't end here, it's just getting started.